everyone, welcome back to my channel. Today we are going to study about evolutes and involutes of a curve. First understand the definition of evolutes of a curve. Let us consider a Cartesian curve y is equal to f of x, p1 be any point on the curve y is equal to f of x such that c1 is the center of curvature for the point p1. The distance from c1 to p1 is our radius of curvature. We already discussed about radius of curvature and center of curvature in previous video. Similarly, P2 be any point on the curve y is equal to f of x such that C2 is the center of curvature for the point P2. Similarly, we can take P3, P4, P5 and so on or any points on the curve y is equal to f of x such that C3, C4 and C5 and so on are the center of curvature for the corresponding points. This shows that for any point on the curve, there is a center of curvature. Now, the definition of evolutes of a curve states that the locus of the center of curvature of the curve C of x bar comma y bar is called evolutes of a curve. That means, these are all the center of curvature. If we join all the center of curvature, we obtain another curve. This curve is nothing but evolutes of a curve. This is a definition of evolutes of a curve, the locus of center of curvature of the curve. That means if we join all the center of curvature of a curve, we obtain another curve. That curve is nothing but evolutes of the curve. Similarly, the original curve when considered to its evolutes is called involutes of a curve. Here, y is equal to f of x is a curve. From this curve, we obtain the evolute of a curve. Hence, we can conclude that the original curve when considered to its evolutes is called as involutes of a curve. This curve is nothing but involute of a curve. From this curve, we obtain another curve. That curve is nothing but a evolute of a curve. This is a definition of evolutes and involutes of a curve. Next, we shall understand working rule to find evolutes. This is very important to find the evolutes of a curve. In first step, we have to find the coordinates of center of curvature given by x bar which is equal to x minus y1 into 1 plus y1 square by y2 and y bar which is equal to y plus 1 plus y1 square by y2. This is very important formula. You must remember how to find the coordinates of center of curvature. We already discussed in the previous video how to find the coordinates of center of curvature. You can see in that video. Here to find the evolutes of a curve, first step is to find the coordinates of center of curvature. After finding coordinates of center of curvature, we have to eliminate x and y from x bar and y bar. After obtaining x bar and y bar, we have to eliminate x and y term in x bar and y bar. In next step, we have to replace x bar by x and y bar by y. Then the relation between x and y is a required equation of a evolute. Here, what's the first step? We have to find the coordinates of center of curvature first, that is x bar and y bar. After finding x bar and y bar, we have to eliminate x and y term in x bar and y bar and we have to form an equation. In that equation, finally we have to replace x bar by x and y bar by y. Then the equation is nothing but a evolutes of a curve. Let us see the problem, how to find the evolutes of a curve. Before going to the problem, let us understand what are all the applications of evolutes and involutes in engineering. Evolutes and involutes have wide range of application in engineering field. In civil engineering, evolutes can be used in computer-aided design, that is CAD systems, for curve and surface modeling, allowing for efficient representation and manipulation of complex geometries. In mechanical engineering, evolutes can be utilized in tool planning for machining operations to ensure optimal cutting paths, reducing machining time and improving accuracy. Involute curves are widely used in gear tooth profiles. The involute profile provides smooth meshing and engagement between gear teeth, resulting in a consistent transmission of rotational motion and torque. In automotive engineering, evolutes are applied in designing the valve profile in engines, ensuring efficient opening and closing mechanism which are critical for engine performance. In aerospace engineering, evolutes can be employed in designing the wing profile of aircraft, optimizing aerodynamic lift and drag characteristics. In robotics, Evolutes can be used in designing the profile of manipulator arms in robots, facilitating smooth and efficient movements. These are all some of the uses of evolutes and involutes in engineering field. Now let us see how to solve problems on evolutes of a curve. Here is the first problem. Find the coordinates of center of curvature at any point on the parabola y square which is equal to 4ax and hence find its evolutes. Here in the given problem, they have asked to find the coordinates of center of curvature first and hence we have to find the evolutes. Here find the evolutes means first we have to find the coordinates of center of curvature only. Here they have mentioned it in the question, find the coordinates of center of curvature for any parabola y square is equal to 4ax and hence find its evolutes. We already know the coordinates of center of curvature is given by the formula x bar which is equal to x minus y1 into 1 plus y1 square by y2 and y bar which is equal to y plus 1 plus y1 square by y2. Here first we have to find x bar. For that we have to require y1 and y2. Hence we have to find y1 and y2 first. For that take the given parabola y square is equal to 4ax. To find y1 means we have to differentiate the equation with respect to x. That is differentiation of y square is 2y into again we have to differentiate y with respect to x, that is dy by dx which is equal to 4a is constant, take as it is, into differentiation of x is 1. Here 2 gets cancelled. Hence we get y into dy by dx which is equal to 2a, or we can take it as y1. dy by dx you can simply write it as y1 which is equal to 2a divided by y. This is our y1. After finding y1 we have to find y2. For that again differentiate y1 with respect to x, we get y2 which is equal to 2a is constant, take as it is, into differentiation of 1 by y is minus 1 by y square into again we have to differentiate y with respect to x, that is y1. y2 which is equal to minus 2a by y square into, here in the place of y1 we have to substitute as 2a by y. Here minus 2a into 2a is minus 4a square divided by y square into y is y cube. This is our y2. y2 is minus 4a square by y cube. After finding y1 and y2, we have to substitute in the formula x bar and y bar. First we have to find x bar and y bar. Here y1 is 2a by y and y2 is minus 4a square by y cube. Substitute in the formula of x bar, that is x bar which is equal to x minus y1 is 2a by y into 1 plus y1 square is 2a by y whole square divided by y2 is minus 4a square by y cube. Here minus into minus plus, hence we get x bar which is equal to x plus 2a by y into, here take minus 4a square by y square to the numerator, that becomes y square goes to the numerator and 4a square to the denominator, into 1 plus, here 2a by y whole square is 4a square by y square. Here 2a gets cancelled, y gets cancelled, hence we get x bar value as x plus, here y gets cancelled means remaining is y square divided by, here remaining is 2a into, here take y square as LCM and simplify, we get y square plus 4a square by y square. This is our x bar. Again y square gets cancelled here and simplify, we get x bar value as x plus, here 1 by 2a into y square is y square by 2a plus 1 by 2a into 4a square is, take as it is, 4a square by 2a. Now here is the x value. So to convert y as x, to simplify further, we can take the given parabola y square is equal to 4ax. So we can take in the place of y square we can substitute as 4ax and simplify. We get x plus, in the place of y square we have to substitute as 4ax divided by 2a plus, here 2a gets cancelled, remaining is 2a. Now 2a gets cancelled here and simplify as x plus, here 2a gets cancelled means the remaining will be 2x. X plus 2x is 3x plus 2a, that is our x bar. X bar is 3x plus 2a. We obtain x bar as 3x plus 2a. Also we have to find y bar, that is y bar which is equal to y plus 1 plus y1 square is 2a by y whole square divided by y2 is minus 4a square by y cube. Here also plus into minus is minus, hence we get y bar which is equal to y minus 1 plus, here 2a by y whole square as 4a square by y square divided by 4a square by y cube. In next step we have to take this 4a square by y cube to the numerator and simplify, we get y minus y cube divided by 4a square into, here take y square as LCM and simplify, we get as y square plus 4a square divided by y square. Here y square gets cancelled. We get y minus y by 4a square into y square plus 4a square. Here take 4a square as LCM and simplify, we get as 4a square y minus y into y square is y cube plus into minus 4a square y divided by 4a square. That is y bar, which is equal to 4a square y minus y cube minus 4a square y. 4a square y gets cancelled. We get y bar value as minus y cube divided by 4a square. Also we have x bar value as 3x plus 2a. Hence we get the locus of the coordinates of center of curvature, that is x bar comma y bar, is our evolutes. To obtain the evolutes of a curve, squaring on both the side of y bar, we get y bar square, which is equal to minus y cube by 4a square whole square. Here minus square is nothing but positive sign of y cube whole square is y power 6 divided by 4a square whole square is 16a power 4. Now to substitute y square value as 4ax. In the given problem they have mentioned the equation of parabola is y square is equal to 4ax. To substitute y square value over here, we can rearrange the term as y square whole cube divided by 16a power 4. Now we know that the value of y square is 4ax. Substituting as 4ax whole cube divided by 16a power 4. Here 16a cube and here also 16a cube. 4 cube is nothing but 64. Hence we get 16a cube gets cancelled. Hence you obtain 4x cube divided by a. This is our y bar square value. Now we have to replace x and y value in x bar and y bar. For that, consider x bar value as 3x plus 2a. Hence we get x value as 3x is nothing but x bar minus 2a. Hence we get x value as x bar minus 2a divided by 3. Substituting x value over here, we get y bar square, which is equal to 4 by a into x cube is x bar minus 2a divided by 3 whole cube. After rearranging the term, we get value as 27a into y bar square, which is equal to 4 into x bar minus 2a whole cube. Now we obtain an equation. This is an equation which represents the evolutes of a curve. Finally, we have to replace y bar by y and x bar by x. That gives the evolutes of a parabola, that is 27a into y square, which is equal to 4 into x minus 2a whole cube is a required evolutes of a parabola. This completes the problem. Here to find the evolutes of the given curve, first step we have to find the coordinates of center of curvature, that is x bar and y bar. Using the value of x bar and y bar, we have to eliminate x and y term in x bar and y bar. After eliminating x and y value in x bar and y bar, we obtain an equation. That equation is nothing but evolutes of a curve. Also in the final step, we have to replace the x bar and y bar by x and y itself. That equation represents evolutes of the given curve. We shall see another problem so you can understand in a better way. Here is the second problem. Show that evolutes of the ellipse x square by a square plus y square by b square, which is equal to 1 is ax whole power 2 by 3 plus by whole power 2 by 3, which is equal to a square minus b square whole power 2 by 3. Here they have mentioned we have to show that the evolutes of ellipse is ax whole power 2 by 3 plus by whole power 2 by 3, which is equal to a square minus b square whole power 2 by 3. In this problem, we have to consider the parametric equation of ellipse is x equal to a cos theta and y is equal to b sin theta. You have to remember the parametric equation of ellipse. This is a standard parametric equation of ellipse, that is x equal to a cos theta and y is equal to b sin theta. First differentiate x with respect to theta, we get dx by d theta, which is equal to a into differentiation of cos theta is minus sin theta. Hence we get dx by d theta as minus a sin theta. And differentiating y with respect to theta, that is dy by d theta, which is equal to b is constant, take as it is, into differentiation of sin theta is cos theta. Here we have dx by d theta and dy by d theta. But to find the coordinates of center of curvature, we have the formula given by x bar and y bar. We have to obtain y1 and y2. That is y1 is nothing but dy by dx, y2 is nothing but d square y by dx square. For that, consider y1. That is y1 is given by dy by dx. We can write dy as dy by d theta and dx as dx by d theta. Here we have value in the form dx by d theta and dy by d theta. So to convert this value in terms of dy by dx, we can write it as dy by dx. We can write it as dy by d theta divided by dx by d theta. If we cancel d theta, the remaining will be dy by dx. That is our y1. Hence we can split dy by dx as dy by d theta divided by dx by d theta. Now we can substitute dy by d theta as b cos theta and dx by d theta as minus a sin theta, which is equal to b cos theta divided by minus a sin theta. Here cos theta by sin theta is nothing but cot theta. Hence we get y1 value as minus b by a into cot theta. This is our y1 value. After finding y1 value, we have to find y2. For that, differentiating with respect to x, we get differentiation of y1 with respect to x, that is y2, which is equal to, here also y1 is in the form of theta, but we have to obtain as d square y by dx square. Hence we have to write d square y by dx square in the form of d by dx of dy by dx, that is d square y by dx square itself. Hence we can write d square y by dx square as d by dx of dy by dx, or we have to substitute a d by dx as d by d theta into dy by dx into d theta by dx. We have to remember how to write this formula, that is d by dx. In first step, we obtain dx by d theta and dy by d theta, but we have to obtain y1 as dy by dx. Hence we have to substitute as dy by d theta divided by dx by d theta. Here d theta get cancelled, we get dy by dx only. In second step, y2 is nothing but d square y by dx square. So d square y by dx square, we can write it as d by dx of dy by dx. Here d by dx, we can write it as, here is this of the form dy by dx, but in y1 is nothing but theta form. Hence to obtain theta form, we can write d by dx as d by d theta into d theta by dx. If we cancel d theta, the remaining will be d by dx only. D by dx, we can write it as d by d theta of dy by dx as it is into d theta by dx, which is equal to, now we can substitute the values. D by d theta of dy by dx is nothing but y1, that is our minus b by a into cot theta, into d theta by dx is, here we have dx by d theta as minus a sin theta. Hence we get d theta by dx is nothing but reciprocal of dx by d theta. Hence we get 1 by minus a into sin theta. You have to write carefully. This is our y2. Now simplify as, we have to differentiate the equation minus b by a into cot theta with respect to theta. Hence we get y2, which is equal to, here minus b by a is constant, take as it is, into differentiation of cot theta with respect to theta is minus cosecant square theta into minus 1 by a into sin theta, take as it is. Here minus into minus plus, plus into minus minus. Hence we get y2 value as minus b by a into a is a square into, here cosecant square we can write it as 1 by sin square. You already know cosecant theta is the reciprocal of sin theta. Hence we have 1 by sin square theta into 1 by sin theta, we can write it as 1 by sin cube theta. y2 value is minus b by a square into 1 by sin cube theta. This is our y2. Now after finding y1 and y2, we have to substitute in the formula of coordinates of center of curvature, that is x bar, which is equal to x minus y1 into 1 plus y1 square by y2. Here we know that y1 is nothing but minus b by a into cot theta, y2 is minus b by a square into 1 by sin cube theta. Substitute here and simplify, we get x is a cos theta minus y1 is minus b by a into cot theta into 1 plus y1 square is 1 plus, here minus b by a cot theta whole square, that becomes positive sign of b square by a square cot square theta, divided by y2 is nothing but minus b by a square into sin cube theta. In next step, here these are all in the form sin and cos. So we can simplify cot theta in terms of sin and cos. You know that cot theta is nothing but cos theta by sin theta. Hence we get a cos theta minus, here we have minus to minus plus, plus into minus minus sin of b by a into cot theta is cos theta by sin theta into 1 plus b square by a square into, here also cot square theta, that means cos square theta divided by sin square theta divided by b divided by a square into sin cube theta. In the next step, we have to take b by a square into sin cube theta to the numerator, that becomes a cos theta minus, here b by a into cos theta by sin theta as it is, into, if we take b by a square into sin cube theta to the numerator, that becomes a square sin cube theta divided by b, into, in the bracket we have to take a square sin square theta as LCM and simplify, we get a square sin square theta plus b square cos square theta divided by a square sin square theta. Now we can cancel the terms. Here b gets cancelled, a square gets cancelled. Here sin cube theta and sin cube theta gets cancelled. Here in the denominator we have sin theta into sin square theta is sin cube theta. Here sin cube theta gets cancelled. And simplify, we get x bar value as a cos theta minus, here remaining will be cos theta divided by a into a square. Here in the bracket we have a square sin square theta plus b square cos square theta. Here we have a into cos theta, all in terms of cos values, but here we have sin value. So using the trigonometric identity, we can change sin square theta value as 1 minus cos square theta. You know that sin square theta plus cos square theta value is 1. So in the place of sin square theta, we can write it as 1 minus cos square theta plus b square into cos square theta as it is. Now multiplying a square inside the bracket, we get as x bar, which is equal to a cos theta minus cos theta by a into, here multiply a square inside the bracket, we get a square minus a square cos square theta plus b square cos square theta. In the next step, we have to multiply cos theta by a inside the bracket. We get x bar, which is equal to a cos theta minus, here cos theta a square by a is a gets cancelled, hence we get minus a cos theta, minus into minus plus cos theta by a into a square cos square theta is, here also a gets cancelled, remaining is a into cos theta into cos square theta is cos cube theta. Here minus into plus minus cos theta by a into b square cos square theta is b square cos cube theta divided by a. Here we have to carefully multiply cos theta by a inside the bracket. Here we have to cancel, here a gets terms here, and we have to simplify like this. This is our x bar. Here plus a cos theta minus a cos theta gets cancelled. The remaining is a cos cube theta minus b square cos cube theta divided by a. Now take a as LCM and simplify as a square cos cube theta minus b square cos cube theta divided by a. Hence we can take cos cube theta as common and simplify as x bar, which is equal to a square minus b square divided by a into cos cube theta. This is our x bar. You have to carefully substitute the terms and simplify. We get x bar value as a square minus b square divided by a into cos cube theta. This is our x bar. Similarly, we have to find y bar value. Y bar is given by y plus 1 plus y1 square by y2. Here we have to substitute y as b sin theta. Y1 is minus b by a into cot theta. Y2 is minus b by a square into 1 by sin cube theta. Substituting all the value here, we get y bar, which is equal to y is b sin theta plus 1 plus y1 square is minus b by a cot theta whole square, that is b square by a square into cot square theta divided by y2 is minus b by a square into sin cube theta. Here plus into minus is minus. Here all the values in sin term. Here we have cot values, so we have to replace cot in terms of sin and cos as b sin theta plus 1 plus b square by a square into cot square theta is cos square theta by sin square theta divided by minus b by a square into sin cube theta. Here plus into minus is minus, and take b by a square into sin cube theta to the numerator. We get y bar value as b sin theta minus a square sin cube theta divided by b into, here take a square into sin square theta as LCM and simplify, we get a square sin square theta plus b square cos square theta divided by a square into sin square theta. As before, we already discussed how to find x bar. In the similar way, we have to find y bar. Here a square gets cancelled and sin cube theta and 1 sin square theta gets cancelled. We get y bar value as b sin theta minus, here a square and sin square theta gets cancelled. Here remaining is sin theta divided by b into a square sin square theta plus b square into, here all the term is sin theta, hence we have to replace cos square theta in terms of sin as 1 minus sin square theta. Next step, we have to multiply b square inside the bracket and simplify as y bar, which is equal to b sin theta minus sin theta divided by b into a square sin square theta plus b square into 1 is b square plus into minus minus b square into sin square theta. Now multiply sin theta by b inside the bracket and simplify, we get y bar, which is equal to b sin theta minus, here sin theta by b into a square sin square theta is a square sin cube theta divided by b plus into minus minus, here bb gets cancelled, the remaining is b into sin theta, again minus into minus is plus, here 1 bb gets cancelled, hence we get b sin square theta into sin theta is b sin cube theta. The next step, here plus b sin theta minus b sin theta gets cancelled, and simplify as before, we get here minus a square sine cube theta divided by b plus b into sine cube theta. Now we can take sine cube theta outside the bracket and b as LCM and simplify, we get y bar value as minus of a square minus b square divided by b into sine cube theta. This is our y bar. Here we find the first step, that is the coordinates of center of curvature, that is x bar and y bar. Here the x bar and y bar does not contain x and y value, we can stop here. But in the given problem, they have asked to show that the evolute value of the ellipse is ax bar whole power 2 by 3 plus by bar whole power 2 by 3, which is equal to a square minus b square whole power 2 by 3. We have to simplify further x bar and y bar as, here x bar is nothing but a square minus b square divided by a into cos cube theta. From this, we can take cos cube theta value as, here to find cos cube theta is nothing but if we have to take a to the left hand side and a square minus b square to the denominator, that becomes cos cube theta, which is equal to ax bar divided by a square minus b square, and cos theta, which is equal to, here cos theta is nothing but if we take 3 to the right hand side, that becomes whole power of 1 by 3. Hence we get cos theta, which is equal to ax bar by a square minus b square whole power 1 by 3. That is our cos theta. Take it is a equation 1. Similarly, we have to find sine cube theta, which is equal to minus by bar divided by a square minus b square. Hence we get sine theta value as by bar divided by a square minus b square whole power 1 by 3. Consider this equation as equation number 2. After finding cos theta and sine theta, in the next step we have to squaring and adding equation 1 and 2. We get, here we have to square and add the left hand side and right hand side separately. Hence we get squaring and adding equation 1 and equation 2, we get cos square theta plus sine square theta in the left hand side, which is equal to, here we have to square and add means ax bar by a square minus b square whole power 1 by 3 into 2, that is ax bar divided by a square minus b square whole power 2 by 3 plus by bar divided by a square minus b square whole power 1 by 3 into 2 is 2 by 3. Hence we get by bar divided by a square minus b square whole power 2 by 3. This is our cos square theta plus sine square theta value. We know that cos square theta plus sine square theta value is 1. By trigonometric identity we have, here substituting cos square theta plus sine square theta value is 1, we get 1, which is equal to, here we have ax bar by a square minus b square whole power 2 by 3 plus by bar by a square minus b square whole power 2 by 3. So we can take the common factor as a square minus b square whole power 2 by 3 in the denominator and simplify, we can write it as ax bar whole power 2 by 3 plus by bar whole power 2 by 3 divided by a square minus b square whole power 2 by 3. This is a LCM for the equation 1, which is equal to, now we can combine these two equations and write it as ax bar whole power 2 by 3 plus by bar whole power 2 by 3 divided by a square minus b square whole power 2 by 3. Now take a square minus b square whole power 2 by 3 to the right hand side and simplify, we get the required equation as ax bar whole power 2 by 3 plus by bar whole power 2 by 3, which is equal to a square minus b square whole power 2 by 3. In the next step, we have to replace x bar by x and y bar by y. We obtain the equation of evolutes of the ellipse, that is ax whole power 2 by 3 plus by whole power 2 by 3, which is equal to a square minus b square whole power 2 by 3 is the equation of evolutes of the ellipse. This completes the problem. We shall move on to another problem. Show that evolutes of a hyperbola x square by a square minus y square by b square, which is equal to 1 is ax whole power 2 by 3 minus by whole power 2 by 3, which is equal to a square plus b square whole power 2 by 3. Here in the given problem, we have to show that evolutes of the hyperbola is ax whole power 2 by 3 minus by whole power 2 by 3, which is equal to a square plus b square whole power 2 by 3. This problem is same as that of evolutes of ellipse. In the ellipse, the parametric equation is given by x equal to a cos theta and y is equal to b sin theta. But in case of hyperbola, the parametric equation is given by x equal to a secant theta and y is equal to b tan theta. The procedure will be same for both ellipse and hyperbola. First, you have to remember the parametric equations of ellipse and hyperbola both. Here, to find the evolutes of hyperbola, the parametric equation of hyperbola is given by x equal to a into secant theta and y is equal to b into tan theta. The procedure will be same for both ellipse and hyperbola. First step, we have to take the parametric equation of hyperbola. Here we have to take the parametric equation of hyperbola as x equal to a into secant theta and y is equal to b into tan theta. Next step, we have to differentiate the equation with respect to theta. We get dx by d theta, which is equal to a is constant, take as it is, into differentiation of secant theta is secant theta into tan theta, and y is b into tan theta. So we get dy by d theta as b into differentiation of tan theta is secant square theta. After obtaining dx by d theta and dy by d theta, we have to find y1. We know that y1 we can write it as dy by dx. We can split dy by dx as dy by d theta divided by dx by d theta. Substitute value here, we get dy by d theta is b into secant square theta divided by dx by d theta is a into secant theta into tan theta. Here secant theta gets cancelled. Hence we get y1 value as b by a into secant theta divided by tan theta. Now we can simplify secant by tan theta as b by a into secant theta, we can write it as 1 by cos theta into tan theta, we can write it as sin theta by cos theta. Hence we get cos theta to the numerator and sin theta to the denominator. Now here cos theta gets cancelled. Hence we get y1 value as b by a into 1 by sin theta. This is our y1 value. After finding y1, what's the next step? We have to differentiate with respect to x. We get y2 value as y2 is nothing but d square y by dx square. Y2 is nothing but d square y by dx square. Now we can split d square y by dx as d by dx of dy by dx. Also we have to split d by dx as d by d theta of dy by dx into d theta by dx. If we cancel d theta, the remaining will be d by dx only. Hence we get d by d theta of dy by dx is nothing but b by a into 1 by sin theta into d theta by dx is, we know that dx by d theta value is a into secant theta tan theta. D theta by dx is nothing but reciprocal of that term, that is 1 by a into secant theta into tan theta. In the next step, we have to differentiate the equation b by a into 1 by sin theta with respect to theta. We get y2 value as b by a into, here 1 by sin theta is nothing but, we can take it as, here before differentiating with respect to theta, take 1 by sin theta is nothing but cosecant theta. We know that sin theta and cosecant theta both are reciprocal of each other. Hence, we can take the differentiation of cosecant theta is nothing but minus cosecant theta into cot theta into 1 by a into secant theta tan theta as it is. Now substitute cosecant value as 1 by sin theta, cot value as cos theta by sin theta. Here secant theta is 1 by cos theta and tan theta is sin theta by cos theta. We get y2 value as minus b by a into cosecant is 1 by sin theta into cot theta is cos theta by sin theta into 1 divided by a into secant theta is 1 by cos theta into tan theta is sin theta by cos theta. Substitute carefully and simplify. Hence we get y2 value as minus, here this is 1 by a sin theta divided by cos theta into cos theta is cos square theta. If we take to the numerator, that becomes cos theta into cos square theta is cos cube theta divided by here one sin theta and sin theta, that becomes sin cube theta. A into a is a square. Hence we get y2 value as minus b by a square into cot cube theta. It becomes cos cube theta divided by sin cube theta is nothing but cot cube theta. Hence we get y2 value as minus b by a square into cot cube theta. Here y1 value we obtained as b by a into 1 by sin theta and y2 value as minus b by a square into cot cube theta. After finding y1 and y2, we have to substitute in the coordinates of center of curvature formula, that is x bar, which is equal to x minus y1 into 1 plus y1 square divided by y2. Here x is a into secant theta, y1 is b by a into 1 by sin theta, y2 is minus b by a square into cot cube theta. Substitute here, we get x bar, which is equal to a into secant theta plus y1 is b by a into 1 by sin theta into 1 plus y1 square is b by a into 1 by sin theta whole square divided by y2 is minus b by a square into cot cube theta. Here minus into minus, that becomes positive sign of this equation. In the next step, take b by a square into cot cube theta. Here x bar, which is equal to a into secant theta plus b by a into 1 by sin theta into 1 plus, here b by a into 1 by sin theta is whole square is nothing but b square divided by a square into sin square theta divided by b by a square into cot cube theta. Here we already know cot cube theta, we can write it as cos cube theta divided by sin cube theta. Hence we get sin cube theta and a square to the numerator and b into cos cube theta to the denominator. We get a into secant theta plus b by a into 1 by sin theta into, here cot cube theta is cos cube theta divided by sin cube theta. Hence if we take this term to the numerator, that becomes a square into sin cube theta divided by b into cos cube theta into, here in this bracket we have to take a square sin square theta as LCM, we get a square sin square theta plus b square divided by a square into sin square theta. Here a square gets cancelled, b gets cancelled. Here sin theta and sin square theta, sin cube theta. Here also sin cube theta gets cancelled, and simplify we get x bar value which is equal to a into secant theta plus the remaining is 1 by a into cos cube theta into a square into, here in the place of sin square theta we have to write it as 1 minus cos square theta plus b square as it is. Now we get x bar which is equal to a into secant theta plus, we have to multiply 1 by a into cos cube theta inside the bracket, and multiplying a square inside the bracket here also we get 1 by a into cos cube theta into a square into 1 is a square. Here a gets cancelled, the remaining is a divided by cos cube theta. Here plus into minus is minus. Here a square into minus cos square theta is minus a square cos square theta divided by a cos square theta is a and cos square theta gets cancelled. The remaining is a divided by cos theta plus b square divided by a into cos cube theta as it is. In the next step, here we have a into secant theta, but here all the three values are in cos form. Hence we have to take this cos theta in terms of secant. We know that cos theta and secant theta both are reciprocal of each other. Hence we can write it as x bar which is equal to a into secant theta plus a into 1 by cos cube theta, we can write it as secant cube theta, minus here a into 1 by cos theta is secant theta plus b square by a into 1 by cos cube theta is secant cube theta. Now we cancel the term plus a secant theta minus a secant theta, and the remaining is a secant cube theta plus b square secant cube theta by a. Take a as LCM and secant cube theta outside the bracket and simplify, we get x bar value as a square plus b square by a into secant cube theta. This is our x bar. Similarly, we have to find y bar value. The formula of y bar is given by y plus 1 plus y1 square by y2. Here we have to substitute y value as b tan theta, y1 is b by a into 1 by sin theta, and y2 is minus b by a square into cot cube theta. Substituting all the value here, we get y bar as y is b tan theta plus 1 plus y1 square is b square by a square into sin square theta divided by y2 is minus b by a square into cot cube theta. The next step, take b cot cube theta divided by a square to the numerator, that becomes a square divided by b into cot cube theta into, here a square sin square theta is LCM, we get a square sin square theta plus b square divided by a square into sin square theta. In the next step, we have to simplify cot cube theta as cos by sin. Hence we get b tan theta minus a square divided by b into cot cube is cos cube theta divided by sin cube theta. So sin cube theta goes to the numerator. Hence we get minus of a square sin cube theta divided by b into cos cube theta into a square sin square theta plus b square divided by a square sin square theta. Here a square sin square theta, a square sin square theta gets cancelled. The remaining is y bar which is equal to b tan theta minus, here sin theta is remaining, sin theta divided by b into cos cube theta into a square sin square theta plus b square. Now we can write y bar as b tan theta minus, here multiply sin theta by b into cos cube theta inside the bracket, we get minus a square by b into, here sin theta into sin square theta is sin cube theta. Sin cube theta divided by cos cube theta is tan square theta. So you can simply write it as minus a square by b into tan cube theta plus into minus minus. Here bb gets cancelled, b into, here sin theta by cos cube theta into 1 is sin theta by cos cube theta itself, sin theta by cos theta is tan theta into 1 by cos square theta, we can write it as secant square theta. You have to write carefully. Here what we have done, sin theta by b into cos cube theta, we have to multiply inside the bracket. In first bracket we have to take plus into minus is minus a square by b as it is into, here we have sin theta by cos cube theta into sin square theta. We get sin theta into sin square theta is sin cube theta divided by cos cube theta. We can write it as tan cube theta. Here in the second value plus into minus is minus. Here b sin theta by b into cos cube theta into b square is bb gets cancelled. The remaining is sin theta by cos cube theta itself. Here we can take sin theta by cos cube theta, we can split as cos square theta into cos theta. Here sin theta by cos theta is tan theta, 1 by cos square we can write it as secant square theta. This is our y bar. In the next step, here we have b tan theta term, but here we have secant square theta term. So to remove secant square theta term, we can write it as y bar which is equal to b into tan theta minus a square by b into tan cube theta minus b tan theta into, we can write secant in terms of tan as 1 plus tan square theta. We know by trigonometric identity 1 plus tan square theta is nothing but secant square theta. So we can write it as secant square theta as 1 plus tan square theta. Now we can simplify inside the bracket. We get y bar which is equal to b tan theta minus a square by b into tan cube theta. Minus into plus is minus b into tan theta. Minus into plus is minus b into tan theta into tan square theta is tan cube theta. We can write here itself. This is tan cube theta. In the next step, plus b tan theta and minus b tan theta gets cancelled, and simplifying we get y bar value as minus of a square plus b square divided by b into tan cube theta. This is our y bar. Similarly, after finding x bar and y bar, the locus of x bar and y bar is nothing but a evolute of a curve. That is x bar and y bar. We know that x bar is a square plus b square by a into secant cube theta, and y bar is minus a square plus b square by b into tan cube theta. In the x bar and y bar we removed x and y term, but in the problem they have asked to show that the evolutes of the curve is given by ax bar whole power 2 by 3 minus by bar whole power 2 by 3, which is equal to a square plus b square whole power 2 by 3. To show the equation, we have to further simplify the equation as x bar is a square plus b square by a into secant cube theta. Hence we get secant cube theta value as ax bar divided by a square plus b square, and secant theta value as, if we take cube to the right hand side, that becomes whole power 1 by 3. Hence we get secant theta value as ax bar divided by a square plus b square whole power 1 by 3. Call this as equation 1. Similarly, where y bar is minus whole power, y bar is minus of a square plus b square divided by b into tan cube theta. That is tan cube theta, which is equal to minus by bar. If we take y to the right hand side, that becomes minus y bar divided by a square plus b square. That is our tan cube theta. Hence we get tan theta value as by bar divided by a square plus b square whole power 1 by 3. This is equation 2. In the next step, we have to squaring and subtracting equation 1 and equation 2. We get, in this problem, we have to square and subtract equation 1 and equation 2. But in case of ellipse, we have square and add equation 1 and equation 2. But to obtain the given result, we have to square and subtract equation 1 and equation 2 here. We get secant square theta minus tan square theta, which is equal to, if we take square both the side, we get ax bar divided by a square plus b square whole power 2 by 3 minus by bar divided by a square plus 2 by 3 whole power 2 by 3 in the right hand side. Left hand side we have secant square theta minus tan square theta. Here secant square theta we can write it as 1 plus tan square theta minus tan square theta, which is equal to, here tan square theta gets cancelled, the remaining is 1, which is equal to, here we can write in the right hand side, this is ax bar divided by a square plus b square whole power 2 by 3 minus by bar divided by a square plus b square whole power 2 by 3. We can write it as ax bar whole power 2 by 3 minus by bar whole power 2 by 3 divided by a square plus b square whole power 2 by 3. If we take a square plus b square whole power 2 by 3 at LCM and simplify, we get this one value. Hence the equation obtained is 1, which is equal to ax bar whole power 2 by 3 minus by bar whole power 2 by 3 divided by a square plus b square whole power 2 by 3. If we take a square plus b square whole power 2 by 3 to the right hand side and simplify, we get ax bar whole power 2 by 3 minus by bar whole power 2 by 3, which is equal to a square plus b square whole power 2 by 3. In next step, we have to replace x bar and y bar terms by x and y. Hence we get ax whole power 2 by 3 minus by whole power 2 by 3, which is equal to a square plus b square whole power 2 by 3 is the required equation of evolute of hyperbola. This completes the problem. Finding evolutes of parabola, ellipse and hyperbola, this was very important problem. They will ask an examination. Till here we studied evolutes and involutes of a curve and problems related to this. This completes the module 1. In next video we study about differential calculus 2, that is module 2. If you have any doubts in module 1, comment below. Hope you all liked the video.